Hello, welcome to my channel. Here we are discussing questions from the topic electricity for Edexcel AS level physics examination. That too from the past 4 to 5 years of Edexcel board exam question paper. Before we start, please like and share my videos and also subscribe to my channel so that you can get notification about my new videos. In fact, these videos are good for other exam boards also, since almost all exam boards include questions from the topic electricity. And this is the third video of the series, and the link to the first two videos are given in the description box, and also the fourth and fifth parts will be given soon. I shall show you how to answer these questions. So let us start with the question number 17. In fact, 1 to 16 are included in the first two videos. So here the question is about the circuit diagram shows three identical resistors and two switches X and Y. The battery has negligible internal resistance. Each resistor consists of a wire of diameter. So the diameter is given, the length is given, and even the resistivity is given. So each resistor consists of a conducting wire. The question is, show that the resistance of one resistor at room temperature is 24 ohms. So let's see what are all the informations given. It's given the diameter. So the diameter is 0.181 millimeter. So we have to change it into meter. So 0.181, the prefix milli stands for or has a value of 10 to the power of negative 3. So we are just, instead of milli, we are putting here, multiplying here with the 10 to the power of negative 3 meters. Then from this we can write the resistance, which is half of the diameter. So this will be 0.0905 times 10 to the power of negative 3 meters. Then the length is given, the length that it is given in centimeter. So 55 centimeter, which is 55 times the prefix centi. It has a value of 10 to the power of negative 2. So multiplying with the 10 to the power of negative 2, that many meters. And even the resistivity is given. And we know that the relation between the resistance, because the question is about calculating the resistance. So resistance is rho L over A. Therefore, writing or substituting the values, the resistivity, which is 1.10 times 10 to the power of negative 6 times the length of the wire, which is 55 times 10 to the power of negative 2, the whole thing over the area of cross section. And the wire is having a shape of a cylinder. So area of cross section is area. Area is equal to pi r square. So which is pi times the radius in meters. It is 0.0905 times 10 to the power of negative 3 the whole square. And please use your calculator. On calculating, this is giving an answer of 23.5 ohms, the resistance, which is approximately 24 ohms. So we are getting the expected value. The question is show that it is 24. So we are getting the answer. Now the next part of the question is, a student suggests that the maximum power output from the resistor in the circuit will be greater than 12 watts. Assess whether the student's suggestion is correct or not. See here there are two switches, switch S and Y. A student suggests that the maximum power output from the resistors in this circuit will be greater than 12. So we know that there is current flow only when the switches X and Y are closed. So here when the switches X and Y are closed, actually we have two branches. Uh, First branch is a series combination of two resistors, and the next one is parallel to that, another resistor. And we calculated the resistance value for each of them. See, just now we calculated each of them has a value of 23.5 ohms. So it is the same for each one. So let us see what is the total resistance of the circuit, because to calculate the power dissipated we need the total resistance of the circuit. So the total resistance of the circuit is, there are two branches, and the first branch, two resistors 23.5 and 23.5 ohms are connected in series. The next one is another 23.5 connected parallel. So we can write the total resistance is, it's a parallel combination of 23.5 parallel 23.5, and to this parallel combination we are adding the value. So I'm see, actually we have the series combination of 223.5, so we are adding 23.5 plus 23.5. Then parallel to that we have another 23.5. Okay, so this is series combination, the total is 46 parallel 23.5. Then this is, um, actually we know that when they are in parallel, the total resistance for parallel combination is 1 over RT is 1 over R1 plus 1 over R2. But we can, when there are only two resistors, we can calculate them as the product over the sum. This is the rule. I'm going to use it here in an easy way. I'm going to use this. This is the way. So the total resistance is the product. It is 46 times 23.5 over 46 plus 23.5. So on calculation, this is giving an answer of 15.7 ohms. Now let us calculate the power. P equals V square over R, and on substitution, see, the battery voltage is 12, so across both the branches it is appearing 12 volt because it is a parallel connection. So this will be giving an answer of 12 square over 15.7, which is giving an answer of 9.2 watts. This is the power dissipation. But the student suggests that the maximum power output in the circuit will be greater than 12 watts. But here we are getting a maximum of 9.2. So the student's suggestion is wrong. So the suggestion is wrong. Okay. Now let's move on to the next part of the question. After switch Y had been closed to a few minutes, the power dissipated by the resistor decreased. Explain why. See, it says that after switch Y had been closed for a few minutes, Y is closed, the power dissipated by the resistor decreases. The switch Y is closed means the current is flowing through that branch. So after a few minutes of current passing through, there is heating effect of current, and the temperature of the resistor increases. So as the temperature of the resistor increases, the power dissipated decreases because power is V square over R. So let us write the answer. When switch Y is closed, there is current flow through resistor R. Power dissipated by the resistor decreases. So let's write. After a few minutes, heating effect of current. Heating effect of current. After a few minutes, there is heating effect of current, and resistance value decreases because the temperature when current is passing, the temperature increases. The temperature is increasing, and the resistance is increasing because it is a metallic conductor, metallic piece of wire. So for a metal, for a solid or for metal, resistance is directly proportional to temperature. So the heating effect of current means temperature increases, therefore resistance increases. So when the resistance increases, R and T are directly proportional, making the power dissipated decreases. And power dissipation decreases because we have the equation power is V square over R. So when current flows through the branch for a few minutes, there is heating effect of current. So the temperature increases and resistance increases. So the power dissipation decreases. Let us move on to the next part of the question. When switch X was open and switch Y was closed, X was open and Y is closed. Calculate the number of conduction electrons passing through the resistor every second immediately after. Calculate the number of electrons, conduction electrons, passing through in every second. After switch Y was closed. So now S is open and only Y is closed. So X is open means now the first branch is not existing. We have only the second branch. Y is closed. So we have only one resistor, 23.5 here. So let us see when switch S is open and Y is closed. So let us start writing the answer. Since only Y is closed, we have only one resistor. The total resistance of the circuit, there is only one resistor, which is 23.5 ohms. Therefore, we can calculate what is the current. So the current equals the battery voltage is 12 over the resistance 23.5, which is giving a value of 0.51 amps. This is the current flow, circuit current flow. And also we know that we have an equation I is Q over T, the charge flowing by time. Therefore, the charge flowing, it is I times T, which is, we have already got the current 0.51. times, the question is for every second. See, the question says for every second. That means the time is 1. Time is 1. So it is 0.51 coulomb. This is the number of charges flowing, but what they want us to calculate is the number of conduction electrons. And we know that 1 coulomb is a collection of electrons. 1 coulomb is a collection of electrons. So let us find out. In 1 coulomb has 1.6 times 10 to the power of 1 coulomb, the number of electrons. This is the charge of the electron. Charge of an electron is 1 point. This is the charge E. Charge of the electron 1.6 10 to the power of 19 coulombs. So we have these many coulombs, and from that we can find out how many electrons are flowing. That means 0.51 coulomb is 0.51 times 1.6 times 10 to the power of minus 19, which is giving an answer of 3.2 times 10 to the power of 18 electrons. This is the answer. Total number of electrons flowing is 3.2 times 10 to the power of 18. 1 coulomb is a collection of charged electrons. So we are this is the charge of the electron E. So we are calculating how many electrons are there in 0.51 coulomb. So it is 0.51 times the charge. So there are 3.2 10 to the power of 18 electrons. Now let us move on to the next question. A filament lamp is marked with the 16 volt 60 watts, and another one is the filament is made from a long metal wire with a diameter. The diameter is given, the resistivity is given, and they are operating with a normal temperature. Calculate the length of the wire in the filament. So here the diameter, so which is the diameter is 0.25 millimeter, or radius is half of that, 0.25 over 2, which is 0.125 millimeter, and I'm changing that one to 0.125 millimeter. The prefix value milli is 0.125 times 10 to the power of negative 3 meters. This is the radius. Now we have the relation resistance R equals rho L times A. See, length you have to calculate. Area we can calculate because radius is known, but the resistance. See, here it is given, it's a lamp with a 12 volt 60 watts. That means the voltage is 12 and the power is 60. Therefore, we can calculate what is the resistance. So, which is we have the relation between voltage, resistance and power. Power is equal to V square over R. From that we can calculate the value of resistance, which is V square over P. That is 12 square over 60. So this is giving an answer of 2.4 ohms. So I'm going to use this 2.4 ohms here. So we have writing L as the subject. L is R times A over rho, which is the resistance is 2.4 and area is pi times radius square, which is 0.125 times 10 to the power of negative 3, the whole square, the whole thing over. The resistivity is 5.6 times 10 to the power of negative 8. On calculation, this is giving an answer of 2.1 meters. So this part is the calculation of resistor. So at resistor, I'm using it here. And we have the relation P is equal to V square over R. Now let's move on to the next part of the question. There are two bulbs, A and B, with the voltage and power indication of 12 and 60 and 12 and 30. The student states that both the lamps will operate normally. Is this statement is correct? So here for A and B, so we have two lamps, lamp A and lamp B. Lamp A is indicated as 12 volt 60 watts. So it is 12 volt 60 watts. And the other one is 12 volt 30 watts. So from this we can calculate what is the resistance. So we have the equation power equals V square over R. Power equals V square over R. From that we can calculate the resistance. Resistance is 12 square over 60. This is giving a resistance of 2.4. It is 2.4 ohms. On the other hand, it is the resistance calculation is 12 square over 30 watts means it is the power. 30 square, 12 square over 30, which is giving an answer of 4.8 ohms. It is double. So you see that resistance of lamp A is less than the resistance of, so resistance of lamp A is less than the resistance of lamp B. Lamp B is 4.8. So here you can see that it is series connection and the voltage is not, the voltage is shared because it's a series connection. So voltage is shared according to their need or according to their resistance value. It is not equally shared. Okay. Therefore, so what is remaining same is the current. So we can use the equation to calculate the power, which is V square over R. So since resistance R is less for A, we can say the power of A is greater than power of B. And the student said both the lamps will operate normally, but their powers are different. Therefore, they will not operate normally because power of A is greater than power of B. So they cannot operate normally. So the student's suggestion is wrong. Student's suggestion is wrong. Because their powers are not the same. Now let us move on to the next question. Two resistors of resistance R1 R2 are connected in parallel. Derive a formula for the total resistance of the combination. So let's draw a circuit of two resistors in parallel. So resistor R1 and resistor R2. So this is R1 and this is R2. They connected parallel across a battery source. So the main current starting from the battery is branched out into two parts. So here it is I, but here it is branched out as I1. There are two branches, so two branch currents I1 and I2 in such a way that I1 plus I2. So again, those two currents I1 and I2, they combined I1, I2, they combine to make the main circuit current I. So we can start answering them. Since the current is branched out, since the current is branched out, uh, we can write the total current. Total current means the circuit current. Circuit current is the total current of branch 1 and branch 2. The current that is starting from the battery. So total current is the sum of I1 and I2, the branch currents. And also we know that V is the same across the parallel branches. So we know that the battery voltage is same as voltage across R1 or it is also across R2 because it is parallel connection. Okay, this is the battery voltage. So let us write the value of, so we know what is voltage, we know what is resistance. So let us write the value of current in terms of voltage and resistor. So this is total voltage over the total resistance. Let me represent it as RG, and portion I1 is voltage across that, which is again V over its resistance, and I2 is voltage across second branch over its resistance. So from here we can say that the voltages from voltage here and voltage here and voltage here we can cancel out, and we are getting an equation 1 over RT equals 1 over R1 plus 1 over R2. So this is the total resistance of the circuit. So the reciprocal of the total resistance is the sum of the reciprocal of the individual resistors. So current is branched out. So we are starting from that. Total current is I1 plus I2. We are writing the value of current in terms of voltage and resistance. So we know that I is equal to V over R, Ohm's law from that. So we are writing and we are getting the equation. Let's move on to the next part of the question. In this, there are 5 resistors M, N, O, P, Q. There are 5 resistors connected and each one is 5 ohm. Show that the resistance between points A and B is between A and B. Between A and B is because it is a total resistance. So here, let us say that P plus Q parallel N, the whole thing, this one, this part, I'm going to call it as loop 1. Loop 1, this parallel combination, I'm going to call it as loop 1. Then the whole thing, including Q, the outer one, this one, the outer one, that is including Q, I'm going to call it as loop 2. So we have two loops, loop 1 and loop 2. Loop 1 is only P and Q and N. This is loop 1, P, Q and N. So loop 1 and 2. So when you are solving these type of questions, you have to solve from the innermost loops. So P, Q and N, that is the innermost one. And first of all, we'll do the series 1, P and Q in series. And that is connected parallel to resistor N. And of course, each one is 5 ohms. Each one is 5 ohms. So let us write what is the total resistance of loop 1. For loop 1, what is the total resistance? Loop 1 total resistance is, it is P plus Q, and that value is in parallel with N. So P plus Q is 5 plus 5. Each one is 5. So 5 plus 5, this value parallel to N. That is again 5. So we have N parallel, 10 parallel 5. This is the R total for loop 1. Now, just now we have seen when the resistors are connected parallel, the total resistance is the sum of their reciprocals. Okay, the equation is this, but we have an easy way to calculate the total resistance. It is the ratio of the product by sum. So directly we will get the value of RT. So I'm going to use this method here. So this will give me an answer of 10 times 5 over 10 plus 5. So this will give me an answer of 3.3 ohms. So R total for loop 1 is 3.3. Loop 1, the innermost loop. Now let us go to loop 2. Loop 2 is this 3.3. Now the loop 2 is R total of loop 1. So it will be like this resistor, which is R total of loop 1 plus we have the other resistor Q. This is the way. So here R total, and for loop 2, that is R total for loop 2. This is a series connection, 3.3 plus 5, which is 8.3 ohms. So this is the total resistance for loop 2. Now let us see what is the total resistance of the circuit. So that is R total for the circuit. R total for the circuit means now we have loop 2 resistors parallel to M. R total. R total is loop 2 resistor, which is 8.3 parallel to M, which is 8.3 parallel to 5. Okay, so this calculation, let us calculate it as RT of the circuit, the total resistance. RT of the circuit, or I can say RT of between A to B, between A and B. This is actually between circuit, or this is between A and B. RT between A and B. This is, we are using the method of the product over sum. 8.3 times 5, 8.3 plus 5. This is giving a final answer of 3.1 ohms. This is the total resistance of the circuit, in the sense the total resistance between A and B. Total resistance of the circuit, or between A and B, it is 3.1 ohms. So please remember, when you are calculating these type of circuits, you start with the innermost loops. So in the innermost loop, actually I can take it as 3 loops. P and Q, one loop. Then P plus Q parallel N is a second loop. But I started that as loop 1, loop 2. Then that resistance is parallel to M. Now let's move on to the next part of the question. The student is told to modify the combination of resistors so that the combined resistance between A and B is greater than 5 ohms. So he has to get the total resistance more than 5 ohms, greater than 5 ohms. See, now we were getting it as 3.1 ohms only between A and B. Resistance of circuit or resistance between A and B, it is 3.1 ohm. But they want it 5. But he cannot change the arrangement of the resistors, but she can replace one of the 5 ohm resistor. So one of the 5 ohm resistance with a 20 ohm resistor. Explain without further calculation which of the 5 resistors should be replaced. So we know that the total resistance of a parallel combination is, total resistance value is less than the even the smallest individual resistor value. Total resistance is less than the individual resistors. So if we replace any 5 ohm resistor by 20 ohm in the inner loops 1 or 2, the total resistance of the loops will decrease further, because the parallel combination means the total value is decreasing. So 20 ohm resistor is a higher value. So if you are see, we have parallel combination in loop 1, and in loop 2 we don't have, but in loop 1 we have parallel combination. So if you use or if you replace any of these 5 ohms in the inner loop with the 20, the resistance value will still decrease. Therefore, the total resistance also will decrease between A and B. So the possibilities, we can replace M, that is the last outer loop. We can replace resistor M by 20 so that the total resistance between A and B will be more than 5. So let us write that answer. Total resistance of a parallel combination RT of a parallel combination is less than even the smallest individual resistor. Total resistance of a parallel combination is smaller than the smallest individual resistor. So if we replace any resistor in loop 1 or loop 2, the total resistance will decrease further. So if we replace any 5 ohm with the 20 ohm resistor in loop 1 or loop 2, the uh, total value of these two loops will further decrease. R total for those loops will decrease further. So the possibilities, we can replace M. Therefore, uh, the student can replace resistor M, the outermost one, resistor M with the 20 ohm, so that the total circuit resistance or resistance between A and B will be more than 5. more than 5 ohm. So we cannot replace any of the internal loops, inner loops. Okay. So we can move on to the next question. The EMF is connected in series with a variable resistor with the resistance R. Terminal resistance of the cell is R. When R is 12, reading of the ammeter is 107 milliamperes. So they are telling when the resistance, assume the value of the variable resistor is 12 ohm, then the current value is I equals 12, sorry, I equals 107. It is 107 milliamps. So there is a prefix milli. So we are multiplying with its value. Prefix milli stands for 10 to the power of negative 3, this much amperes. This is the current. And what is happening here is the circuit is switched on for 300 seconds. In this time, 50 joule of energy is transferred by the cell. 50 joule of energy is transferred by the cell. So energy transferred. So we have energy. Energy transferred is 50 joules. These are the informations given. Now 50 joules of energy transferred means the EMF. So the EMF, this is total voltage here. We can call it as the EMF. Okay. So this EMF, so EMF is marked here. So this is the EMF here. We can write this as the EMF. Okay, EMF is E. It is already marked here. So this EMF equals, so see we have a relation relating the basic relation in electricity. Voltage is the energy transferred by unit charge. Energy transferred by unit charge. So this is equation for voltage. So here the cell transfers 50 joules of energy means the EMF equals energy transferred divided by the charge. Let us write it as capital Q. Now, so energy transferred is given here. So let us write. So how much is the energy transferred? Energy transferred is 50 joules. 50 over what is the value of charge? See, we have an equation. See, there is a current given here. There is current and also there is a time given. So we have a relation between current, charge and time. Therefore, charge is IT. So this is the equation I'm going to use. Instead of Q, I'm going to use the equation Q is IT. So which is 50 times, what is the current? It is 107 times 10 to the power of minus 3 times 300. And this is giving an answer of the EMF is coming as 1.56 volts. Please make use of your calculator. EMF is 1.56 volt. But the question is to calculate the internal resistance R. So it's a 5-mark question. And we know there is a relation relating internal voltage E equals I of R, terminal PD, plus the lowest voltage, or E equals I of R plus R. Here we know what is the current and we know what is the EMF. Therefore, from here we can find out how much is the sum of the total. That is 1.56 over The current is 107 10 to the power of negative 3. So from here I'm getting an answer for a total resistance R plus R. When I'm dividing 1.58, I'm getting a value of 14.57. 14.5, approximately 14.56 ohms, the total resistance. Therefore, R equals 14.56 minus the resistance value is given here. R is 12 minus 12, which is giving an answer of 2.56 ohms. This is the resistance value, internal resistance. So we started with the EMF or the voltage. I started with this equation. Voltage is energy transferred over charge. So from here I started. I'm using this equation here. Then I calculated the EMF. Then I related EMF with the total resistance, the load resistor. So from that relation we are calculating what is the total resistance, and from that the internal resistance. Let's move on to the next part of the question. Increasing R would make a terminal potential difference value closer to E. Explain why without further calculation. Part B. So here, increasing R decreases the current, isn't it? Increasing R would make the terminal PD difference voltage across R, terminal PD, terminal voltage closer to E. Explain why. So increasing R will decrease the current, and we know that when current flows the cell, some current or some energy is lost, or some PD across the internal resistor. We say that there is a lost volt. So when current decreases, the lost volt is also decreasing. Okay, so here we can start with when the resistance increases, current I decreases. Current I decreases. When resistance increases, current I decreases. So when current I decreases, so lost volt in the cell, which is equal to I times R, also decreases, because I decreases means the lost volt, the term IR decreases. IR decreases. So when IR decreases, we know the equation is E equals the terminal PD V plus the lost volt IR. So the term IR decreases means the terminal PD is increasing. Or we can say that is V equals E minus IR. Okay. So as IR decreases, V increases. Terminal PD. V is terminal PD. The terminal PD is increasing. V EMF is V plus IR, or V equals E minus IR, and we have the term IR decreases, so V increases. V increases to keep EMF as a constant. V increases to keep EMF constant. Now the next part of the question is, an ammeter is added to the circuit. So there is an ammeter. Explain how the circuit can be used to determine the value for using a graphical method. So here there is a variable resistor is used. And again it says that using a graphical method. It is using a graphical method. So we have already studied the graph relating the current and the terminal PD V. Terminal PD, this is terminal PD. The terminal PD V. And we know that, or we have seen that this graph, it is a line sloping down. So this is the, okay. And we know that the gradient for such a graph, the gradient equals negative R. So the question is how this can be used to find the value of R. So this is what we have to do. We have to plot a graph of terminal PD and I, and then plot the graph, find the gradient. So here you can see that there is a variable resistor, and across that variable resistor we can measure the voltage. So take reading of voltmeter and the corresponding current reading for different values of R. Then plot the graph. So let's start answering it. So first one, take reading of voltmeter and corresponding reading of voltmeter and corresponding ammeter, that is the current, for different values of resistors. See, this is a variable resistor. You can adjust the resistance value. So for different values of resistors, measure the voltmeter and the ammeter. That means you are measuring the current and voltage. Then we have to plot the graph. So next step is plot a graph of voltage against the current as shown. So a sample is shown here. Then find the gradient. Which is equal to negative R. So R is equal to negative of the gradient. I've written here in short, take the reading of voltmeter ammeter, but for exam please try to write the full words. Take the voltmeter reading and corresponding current for different values of resistor and plot the graph. Now the next question is nichrome wire of length and a cross-sectional area. The resistance of the wire is to calculate the resistivity. I think this is a very direct question. Everything is given. Calculate the resistivity of nichrome. So we have the relation R is equal to rho L over A. We want to calculate the resistivity R A over L. Just substituting the numbers, which is equal to the resistance is 2, and it has a length of meter. This is L, and cross-sectional area directly given. So A, which is 2.5 times 10 to the power of negative 7 over the length is 0.45 meters. So on calculation, it is giving an answer of 1.11 times 10 to the power of negative 6 ohm meter. So resistivity, see here the unit is not given, so make sure you are learning even the units. Sometimes they won't give you the unit, they'll ask you to complete it. Now the next part of the question is a potential difference of 3 volt is applied across a nichrome wire. Calculate the drift velocity of the conduction electrons in the nichrome wire. The number of conduction electrons. Here a PD of 3 volt V is applied across the nichrome wire. The number of conduction electrons, that is N, is given. Calculate the drift velocity. So we have an equation relating current. It is N times charge times the drift velocity times the area. So you can make use of the data from the first part also. And here there is the value of voltage is given, and we know that even there is a resistance of 2 ohms. So current we can write from here, and we have to get the value of V. So let us write V as a subject. It is I over N, Q and A, which is equal to, actually the current value is not given directly here, but we know that the current is, see here the voltage is given, resistance, the previous part it is given. Therefore, we can substitute V over R. So this is what I'm going to do. In place of I, I'm going to write it as, it is V over R. So this is current. Then in the denominator, NQA, substituting everything. So drift velocity V. So the voltage is 3 over the resistance is 2, and density is 9 into 10 to the power of 28 times charge of the electron, 1.6 times 10 to the power of minus 19 coulomb. So it is 1.6 times 10 to the power of minus 19, that is this one, QE, times the area, even the area is given, which is 2.5 times 10 to the power of minus 17. Please make use of your calculator to substitute all the values and calculate. So the total value is 4.17. So V over R, it is taken as I. Okay, the total value is coming like 4.17 times 10 to the power of minus 4 meters per second. This is the value of the drift velocity. That was a direct question. Now let us move on to the next part of the question. A student suggests that the drift velocity will double if the length of the wire used in the circuit is halved. Comment on this suggestion. The student suggested that the drift velocity will double if the length of the wire used in the circuit is halved. So what we know is when length is halved, okay, student suggests that the drift velocity will double if the length of the wire is halved. So let us start with the length of the wire is halved. When the length of the wire is halved, what we know is resistance and length are directly proportional. So when length of the wire is halved means the resistance become half. So the current will be doubled. So when the current is doubled, definitely the drift velocity will increase. So the student's suggestion is wrong. So let us start with when L is halved, that means the resistance is halved. Length is halved. The resistance R is also halved. That means R and L are directly proportional. So current will be doubled. So current will be doubled. When the resistance is halved, current will be doubled because we know that V is equal to I times R. So when R is halved, current will be doubled to keep the voltage constant. Now we have the relation, so we can write as per the relation I equals N Q V, drift velocity times A, as I increases, drift velocity V increases. So the student has a suggestion, the drift velocity will double. Drift velocity will double if the length of the wire used in the circuit is halved. So as per the relation, as the current is resistance is halved, the current is doubled. So the current is doubled means the drift velocity also is doubled. So suggestion is correct. Okay. Now let us move on to the next question. There is a parallel combination of 3 and 6, and then there is connected in series with the 4. Calculate the number of electrons passing point X each second. Point X is here. The number of electrons passing means we have to calculate the current I. Then only we can calculate what is the number of electrons passing. So anyway, let us start with the total resistance. The total resistance of the circuit is, it is a 4 ohm plus, it's a parallel combination of 3 ohm and 6 ohm, okay, which is equal to 4 plus and like earlier, total resistance of parallel combination is 1 over R1 plus 1 over R2, but we can calculate RT as the ratio of their product and the sum. So I'm going to use this method. So it is 3 times 6 over 3 plus 6. Okay. This is giving a total resistance of 6 ohms. So total will be 6 ohms. So circuit resistance, or the total resistance is 6 ohms. Therefore, let us see what is the current, circuit current. How much is the circuit current? The total current I. But as you see, this total current I here branches as I1 and I2. Actually, we have to know how much is this I2. Okay, so first of all, let us find out I, which is 12 over 6, which is 2 ampere. This is 2 ampere. Then, but we know something like since it is a parallel connection of 3 and 6, whatever is the voltage across this 3 ohm resistor, same will be the voltage across the 6 ohm also, because they are parallel connection. Okay, so we can say since 3 ohm and 6 ohm are parallel, V of 3 ohm equals V of 6 ohm equals the battery voltage, V of the battery. So finally we can say V across 6 ohm equals, it is not the battery voltage here, V and 6 are same, which is equal to V of battery minus the drop across this resistor. So this is the current here. So we have some resistor voltage drop across this 4 ohm resistor. So which is the voltage drop across the 4 ohm resistor. So let us calculate what is the voltage drop across the 4 ohm resistor first of all. The current flowing through it, that is I times R, which is 2 times 4, which is 8 volt. This is the drop across 4 ohm. Therefore, as a part we can write here, that is voltage across 6 ohm resistor will be 12 minus 8, which is 4 volt. So we reach till here. The voltage across this resistor will be 4 volt. Now I don't have place here. I'm sorry. So I'm writing it here. After this, I'm writing it here. So we reached till here. What is the voltage here? Therefore, I can calculate what is current I2. Therefore, I2 is the branch current. Its voltage, we got it as 4. So I2 is 4 over 6, which is 0.66, this much ampere. 0.67 we can write it, 0.666. So it is 0.67. Now what they are asking is, what is the number of electrons? Number of electrons passing through point P. Number of electrons passing through point P is uh, in each second. So again, time is taken as 1 second. So I2 is this much, means that is I through point X equals 0.66 amperes. This is I through X. So number of electrons passing per second. So number of electrons passing per second equals 0.66 over the charge of an electron, 1.6 into 10 to the power of minus 19. This is giving an answer of 4.2 times 10 to the power of 18 electrons per second, because we are calculated per second, because here they are asking what is the current? 0.66. That means 0.66 coulombs of charges flowing through that point. Therefore, we are finding how many electrons are there. Total coulomb divided by the number of charges. So I through point x is 0.66 means the number of charges passing is 0.66. So from that we are calculating the total charges we know, and the charge of one electron we know. Therefore from that we are calculating how many electrons are passing. Total charge. So I can even write it here. The current through point x is 0.66. That is 0.66 coulomb per second. This many coulombs are passing per second. That is why we are dividing that by the charge of an electron. So let us move on to the next part. Another resistor Y is added to the circuit as shown. So the student wrote the statement. When the resistor Y is added, the resistance of the parallel section increases. The resistor of the whole circuit increases. Therefore, I square R, the power dissipation increases. Evaluate the student statement. So let us see one by one. When resistor Y is added, the resistance of the parallel section increases. This is the first statement he has. Statement number 1. Then statement number 2 is resistance of the whole circuit increases. So this is the second statement. So let's see. So if resistance Y is added in loop 1, in that loop, the first branch current is increasing. That is, it is 3 plus Y. That means the resistance of loop 1 increases. So let us start with the statement. As Y is added, RT of that branch. Let us call this as loop 1. Okay, that branch means loop 1 increases because you added a new resistor. So R total of loop 2. So let us take the whole thing as loop 2. This one, loop 2. Let us take resistance of loop 2, which is equal to 3 plus Y parallel 6. Okay, also increases. Total resistance of the parallel combination is also increases. So this is what the student said. When resistor Y added, the resistance of the parallel section increases. Parallel section means this loop 2. So here we can say first statement is correct. For the student, the first statement is correct. Then he said the resistance of the whole circuit increases. So that is also correct. Second statement also correct. For the student, the first and second statement correct. So here I can write, so R of the circuit increases, because for the parallel section it is increases plus 4 ohm, the total resistance increases. So for the student, the first and second statements are correct. Now when the total resistance increases, when R circuit, R total, that means R circuit increases, what we are getting is I of the circuit decreases. So when I decreases, so the power dissipation by the whole circuit, power dissipation by the whole circuit decreases as per the equation P equals I square R. The student is wrong. So last statement is wrong. That last statement means this is, he said P is equal to I square R 3. So last statement wrong. Student said the total power increases, but since the total current is decreasing, the power dissipation decreases by the equation I square R. So let's move on to the next question. A student set up the circuit shown. The battery had a negligible internal resistance. Determine the milliammeter reading when the temperature of the thermistor is 54. Let's see where is the temperature 54. So 54 is 50, 52, 54 here. So 54 here means the current is approximately, this is the current it is coming. Okay, so let's start writing that. So let's write when temperature equals 54 degrees centigrade, I equals, it's not I, resistance. Resistance equals 1 kilo ohm. This is from graph. From graph, this is the number we are getting. So when it is 54 like this, we are getting the resistance 1 kilo ohm. Now they are asking you to calculate the milliammeter reading. So let's go back to the circuit. So we got the resistance of the thermistor. So this is resistance of the thermistor. We got it as from the graph. We got the number resistance. So from here we are getting the resistance of the thermistor, which is approximately 1 kilo ohm we are getting. Okay. So from this now we can calculate. So now we know all the three resistors, 3K and 1K are in series, which is parallel to 2K. Therefore, we can calculate what is the total resistance. So we are going to calculate the total resistance. So R total equals, we have 3K plus 1K. They are in series. Parallel to that, we have, see, 3 and 1 series, and parallel to that there is a 2 ohm resistor. 2 kilo ohm resistor, I mean 2K. So this will be 4K parallel 2K. So I'm going to use the rule 4 into 2 by 4 plus 2, that is 8 over 6. 8 over 6, it is giving an answer of 1.33. So it is 1.33 kilo ohms. I can write it as 1330 ohms. This is the total resistance. Now after getting the total resistance, we can calculate I circuit, which is the battery voltage was 12 over 1330. On calculation, it is giving an answer of 9.022 10 to the power of negative 3 amps. But they want the answer in determine the milliammeter reading. Yes, because it's given specifically that there is a milliammeter used. So it is a milliammeter used here. Therefore, this is amperes to milliamperes. You have to divide, multiply with the 10 to the power of 3000. I mean 10 to the power of 3 or 1000. So it is 9.022 into 10 to the power of negative 3 ampere to milliampere, 10 to the power of 3, which is giving an answer of 9.022 milliamperes. So this is the milliammeter reading. Now we'll move on to the next part of the question. Explain how decreasing the temperature of the thermistor affects the power dissipated by the 2 kilo ohm resistor. Do not include calculation in your answer. Explain how decreasing the temperature of the thermistor affects the, okay. So when we are decreasing the temperature, so we can write as temperature decreases, resistance of the thermistor increases, because we have a relation resistance of the thermistor is inversely proportional to the temperature. So when temperature decreases, the resistance is increasing. So the resistance decreases, when the resistance increases, let's go back to the circuit. The resistance of the thermistor is increasing. That means the branch current is increasing. This branch current, that is 3 plus the resistance, the branch current is increasing. But we know that the voltage drop across these two branches, it remains the same. So here I have the voltage across the resistor, and here I have the voltage across 3 plus the resistance what we are getting now. So 3 plus R of the thermistor. So it remains the same. So whatever be the value of the resistance, whether it is increasing or decreasing, okay, but voltage drop R remains same as they are connected. They are connected parallel, as they are connected parallel. How the decreasing the temperature of thermistor affects the power dissipation. So power dissipated by 2 kilo ohm remains the same. Remains the same because we have the equation power is equal to V square over R. So resistance is the same for R, fixed resistor. The voltage is also the same. Therefore, the power dissipated by 2 kilo ohm remains the same. Now let's see the last part of the question. The tungsten wire used in a filament light Complete the sketch graph to show how the current varies with the potential difference for the filament lamp. And this is initially for initial voltages. The along with the voltage, current increases, but it changes like this. Similarly, the other part also, it so neatly symmetrical one. Okay, initially it increases and it remains the same. Now let's see the next part. Calculate the drift velocity of the electron in the tungsten wire. Number of charge carriers. I think this is a direct question only. It looks like a direct question. So here the resistance is given. The diameter and the diameter, it is 0.46. Therefore R is equal to 0.23 millimeter, which is 0.23 into 10 to the power of negative 3 meters. And the length is 580. So length is 580 times 10 to the power of negative 3 meters. When there is a current, the current is given, potential difference V is given. Yeah. So we have the equation resistance R is equal to rho L over A. Sorry. Calculate the drift velocity. So current I equals Q NQVA. Therefore, the drift velocity is I over NQA. And we can calculate the current. There is a current of 0.44, so 0.44 over the number charge density is given 1.26 times 10 to the power of 29 times charge of the electron. This is 2-3 questions we have done in this video itself. Now this is the third question we are doing. Now area is pi times the radius, it is 0.23 times 10 to the power of minus 2 the whole square. On calculation, all of them on calculation, we are getting an answer of 0.0131. This is the drift speed meter per second. So it is 0.013 meter per second. Now the next part of the question is deduce the temperature of the filament. So here, when the potential difference across the filament is 140 volt, it is already given in the first part, and the current is 0.44. So there is a voltage and there is a current. Deduce the temperature of the filament. So here the temperature and resistivities are given. So we have to calculate the resistivity, and using that resistivity we can say which is the temperature. So what we can do is the relation relating resistance, resistivity L over A. We have to calculate the resistivity. So it is R over, okay, or we can write directly this one, rho equals R A by L. Now the resistance, it is not given. Instead of this resistance, I'm going to use the equation V over I. This V over I I'm going to use. which is which is multiplied by A over L. Now from here, I can calculate the resistivity. What is the voltage given? It is 140 over the current is 0.44 times the area of cross section and L. Length is given in the first part of the question. The length is given. It is 580 times 10 to the power of minus 3. It is length is 580 times 10 to the power of negative 3, and the area is pi times r square. So here the r value we have 0.23. So this is 0.23 times 10 to the power of negative 3 the whole square, and on calculation we are getting the resistivity as 9.1 times 10 to the power of negative 7 ohm meter. So now let us check 9.1. So we can see that the closest one is 9.04, which is at a temperature of 2700. So closely matches with the closely matches with the resistivity value at 2700 degree centigrade. So the answer is temperature equals 2700 degree centigrade.